Hello everyone. In this session, we are going to study the main sequence stars. First topic is luminosity. Second topic is stellar equations. Third topic is dimensional analysis. Fourth topic is a critical test of hypothesis. And the final topic is a minimum mass of stars. First topic is luminosities. So we have really big questions about the stars. The main sequence stars correspond to hydrogen burning stars. We are wondering if the main sequence stars, like our suns, burn the hydrogen at the centers. So we'd like to make a hypothesis. The main sequence stars burn hydrogen in the cores. Then we'd like to examine if the hypothesis can explain the following observations of the main sequence stars. First one is if we look at the HR diagram, log L is a vertical line and the horizontal line is a log T. T is the surface temperature of stars. Then main sequence stars follow the straight lines. And also the luminosity is proportional to the cube of mass of stars. So if you look at the open clusters, this is a typical HR diagram of the open clusters. So as I explained, we could find the straight lines. As you easily discovered, actually you can the two different slopes. So we'd like to explain these two slopes of straight lines. Okay. Then stellar equations. A star burning hydrogen at the center in thermal and hydrostatic equilibriums. We use three assumptions. First assumption is uniform compositions. And the second assumption is negligible radiation pressures. Third assumption is constant opacities. So from the second assumption, negligible radiation pressures. So pressure is determined by gas. So we use the equation of state for ideal gas. P is equal to the K over mu m sub h rho T's. One of the equation, maybe you need an explanation. This is the generation of energy by the nuclear reactions. L sub nuc is proportional to the density and temperature to the N. N is the power index. Okay, so we are going to use this equation. First equation is hydrostatic. The second equation, mass conservation. Third equation is a flux determined by the temperature gradient. And this is the energy production rate is L nuc is equal to the gradient of the flux. The last one is pressures is determined by the gas pressures. To solve these equations is quite difficult. But we'd like to find some characteristic of this equation, and we use dimensional analysis. So in the dimensional analysis, we considered all the quantity is expressed by the mass. So total mass of the star is expressed as capital A. If you take a small region of the stars, some region of the stars, mass inside of this sphere is expressed as lowercase of the a. The positions R is a distance from the centers. Also, instead of R, we could use M, is a mass inside of some spheres. Then fractional mass we could express X is M over capital M. So X is between the 0 correspond to the centers to the ones. 1 correspond to the surface of the stars. Then all the physical quantity is expressed. For example, R is a product of the two parts. First part is F sub 1 is a non-dimensional functions. And the dimensions is included R sub stars. So we considered R is expressed the product of the two functions. First one is F sub 1, dimensionless functions. and R star has a dimension. Also rho is a dimensionless F sub 3 times rho stars, and F is a F sub 5 times F stars, and pressure and temperature is also dimensionless function times a dimension P stars, and the temperature is a dimensionless function of the F sub 4 times T stars. Then we'd like to write down the equations using these dimensionless functions and the quantity with dimensions. For example, we consider the hydrostatic equilibrium. Pressure gradient is equal to the gravities. If you write a round P round M, then this expressed stars times round F sub 2 over M round M over capital M. So round P round M is expressed P stars over capital M round F sub 2 over round X. You can express. And the right hand side is expressed minus G M over 4 pi R to the 4. So this is going to be expressed G M over R sub stars to the 4th times minus X over 4 pi F sub 1 to the 4th. So these two equations have to be the same. So these two equations is going to be same. So you can express P sub stars over M round F sub 2 over round X equal minus Gm over R sub stars to the 4th times X over 4 pi F sub 1 to the 4th. Then you could pick up the only dimensional quantities, compare the dimensional quantities, and also the dimensionless quantities. So in this case, you can choose the negative signs. So for the dimensionless quantities, we have equations. Round F sub 2 over round X is equal to the minus X over 4 pi F sub 1 to the 4th. For the dimension, P sub star over M equal Gm over R sub star to the 4th. So from the single equations, we could derive the two equations. First equation is responsible for the dimensions, and the second equation is responsible for the structures. Okay, so we have these two equations as I explained. Then all the equations, we could use the same method to derive the equations with non-dimension functions and the equation with dimensions. So inside of the blue box corresponds to the non-dimension functions. This expresses the shape of a profile can be obtained by solving these equations. So this shape of the profile is the same in all stars. And the dimension you can find inside of the green box. This dependence of the physical properties on stellar mass. Stellar profile differs by a constant factor determined by the mass. Then, for example, we'd like to check the luminosities. So we have an equation for the pressures. Comes from this equation. Pressure is expressed as Gm square over R sub star to the 4th. And the density is M over R cube. So density, so pressures and density. And temperature, this temperature comes from these equations, binary equations. Then we'd like to use these three equations. And the pressures equation substitute here, and density substitute here. Then you could express the T sub stars expressed this equation. T sub star equal to mu m sub h g over k times m over r sub stars. So this is exactly equal to this equation. And the flux equation, you can use this third equation here. Then you can substitute this t into this t to the fourth. Then you will get this equation. So F sub star is proportional to the m cube. So at the surface, luminosity is proportional to the m cube. So as I explained, we could explain the observations. Luminosity is proportional to the cubic of the mass of the stars. We could consider the radius. And temperature is expressed. These ones I have explained. And also density and the flux is here. Then you can substitute density is here and temperature is here. Then you could express the flux with this equation. And also in the last case, I explained the flux is here. And this is exactly equal to the same equation, flux. So by this same flux, this should be the equal. So from this equation, R is expressed with the m. R is proportional. M to the power index is n minus 1 over n plus 3. So at a stellar radius x equal 1, in the CNO cycle, n corresponds to the 16th. And then you can calculate is m to the 15 over 19th. In the case of the PP chain, n equal 4. So R is proportional to m to the 3 over 7. So we have a different power loss. In all cases, the radius increases with increasing mass. Okay, this is the end of this session.